All right, for this lesson, we're going to be dealing with solving problems involving rational equations. So the problem solving is where we usually run into issues because we need to first be able to form the correct rational equation, and then we need to do the correct process for solving it. So obviously, the first step is going to be reading through the problem carefully and understand what's being asked. So we're going to give variables for the unknowns. Typically, we can only do it for a singular unknown quantity, more often than not, the one that is actually being asked for, but there are some exceptions to that, as we'll see. We're going to write an algebraic equation, or a rational equation in this case, to represent the information. We're going to solve it, and then the big one with this is when we state the solution, we're going to state the solution as a statement or a sentence, and double check to make sure that the solution actually makes sense given what we have. One of the most common ways we see this is distance, speed, time problems, where we have this nice little triangle here that tells us that speed is equal to distance over time. We know that time is equal to distance over speed, or that distance is equal to speed multiplied by time. Because we're dealing with rational expressions, we're likely going to wind up with one of these two cases. So for the first question, it says, competing in an endurance race, Shannon cycled for 120 kilometers, then swam for 12 kilometers. Her average cycling speed was 8 times faster than her average swimming speed, and she took a total of 9 hours to complete the race. If her average swimming speed is s, use the information to complete the table. So what do we know? We know that she cycled for 120 kilometers. We know that she swam for 12 kilometers. And we know that her cycling speed was 8 times what her swim speed was. Now, it told us the total time, but not the individual times for the two different parts. So that's where we're going to go back to our time formula, as we can see up at the top here. And we know that time is equal to distance over speed. So if I take the distance that I was given, 120, divided by the speed I was going at, 8s, that's how much time she spent cycling. If I take the distance for swimming, 12, divided by the speed for swimming, just s, that is the time that she spent swimming. Now, where the total amount of time comes in is I know that the total amount of time was the time that was spent cycling combined with the time that was spent swimming. And that gave me the total of 9 hours. And now I have a rational equation in one variable. From this point, I'm going to multiply every single term by the lowest common denominator, which in this case is just my 8s. So like what we did in the previous ones, I'm going to take 8s times 120 over 8s plus 8s times 12 over s is equal to 8s times 9. I'm going to divide out the denominators, so the 8s is going to be gone from the first term, the s is going to be gone from the second term, and if I want to in this step, I can multiply this out, or I can save that for the next one. And I'm going to say that I'm left with 120 plus 8 times 12 is equal to 8s times 9, or that 120 plus 8 times 12 is 96, is equal to 8s times 9 is 72 s's. When I combine the constants, I get 216 is equal to 72 s's. And when I divide both sides by 72, 3 is equal to s. And then I'm going to write a statement. Her average swim speed was 3, and this is measured in terms of the distance, kilometers, over the units for time, which is hours. When we move on to the second question, where it says that St. Andre Students' Council is traveling from Knoxtown to Harperville for the Students' National Conference. From the travel budget allotted for the trip, the St. Andrews Students' Council has two options. They can leave tonight by bus, or they can save 3 hours by leaving tomorrow morning and using the express train, which travels 25 kilometers per hour faster than the bus. If the distance between the two is 1,500 kilometers, determine how long it would take by express train. And we're going to do this once again by creating our little chart. The two options that I have are either I can go by train or by bus. Doesn't matter which one you put where, so I'm going to say that the first one is going to be by bus, and the second one is going to be by train. Then I also know that I'm going to have my distance in kilometers, my speed in kilometers per hour, and my time in hours. Now, in both cases, we're traveling the same distance, 1,500 kilometers. The second thing is we don't know what the speed is. So I can say that the slower one is S, and if the other one is 25 kilometers per hour faster, that's just S plus 25. Finally, I get to the time. The time, like we know from before, is going to be the distance divided by the speed. The only other piece of information that I have here is that I can save 3 hours if I use the train, which means the difference in time that it takes for the two is going to be 3 hours. Now, you got to be careful because the order you subtract them in is going to be different. If it's going to be a positive number, or 3, then I need to take my slower one, which is going to be the bus, and subtract from that the time for the faster one, the train, and that's going to give me that 3 hours. At this point, I can factor down, and I can see that the lowest common denominator is s and s plus 25 because there's no common factors. So I'm going to multiply every single term by s and s plus 25. Divide out the denominator, so take away s from the first one, s plus 25 from the second one. And then what I'm left with is 1,500 s plus 25s minus 1,500 s's is equal to that 3s and s plus 25. I'm going to expand everything out and get 1,500s plus 37,500 minus 1,500s is equal to 3s squared plus 75 s's. And the thing that I noticed right away is that I have positive 1,500s, negative 1,500s, and those two are going to cancel each other out. And because this is quadratic, I'm going to move that 37,500 to the other side and get the quadratic equation in general form. 0 is equal to 3s squareds plus 75 s's minus 37,500. From this point, I'm going to factor it, pulling out the common factor first, s squared plus 25s minus 12,500. And then I look for two factors of negative 12,500 that add up to 25. And I get 0 is equal to 3 s plus 125 and s minus 100. Take my two factors with an s and say that s could either equal negative 125 or s could equal 100. And for obvious reasons, that negative answer doesn't make sense. I'm not going to be traveling at a negative speed. So the only answer that realistically makes sense is that s has to be 100. Now in this case, that is my speed of the bus, but it didn't ask for the speed of the bus, it asked for the time of the train. So if I know my time of the train is 1,500 over s plus 25, then I need to put that back in with the value of s. If s is equal to 100, then the train time is going to equal 1,500 over 100 plus 25, which is the same as 1,500 over 125, which gives me 12 hours. And then I write my quick statement. It took the train 12 hours. And that's it. All right, go ahead, try some of the practice.